Hello, I'm Alexis Pellick with Process Development Forum, and I'm here today with David Walton, VP of Manufacturing, and Christopher Rudenholm Hansen, Manager of Purification at CMC Biologics. And today we're going to talk about single-use components in bioprocessing. David, Christopher, thanks for joining us. Can you briefly describe your company, what products or services it offers in this area, and your role in the company?
CMC Biologics is a contract biologics manufacturer. We actually have two sites, one based in Copenhagen and one based in Seattle. In Copenhagen, we actually run mammalian and microbial products, and in Seattle, we just run mammalian products. We go right the way through from TOC through to in-market supply, and the American facility is going for in-market supply this year.
What significance do you think single-use components have in your work?
They're having more and more significance as time goes by. The actual product now is actually being made in the components. So if you're looking at bioreactors, say, there is a trend towards the product actually being made in single-use bioreactors. And here at CMC, we've just installed a 2,000-liter bioreactor, which is the first in Europe, and we're intending to go in market supply with. So I think the significance is that the actual components are getting larger and more suited to in-market supply.
Would you describe this as a revolutionary change or a small development?
Recently, it's become more revolutionary. Again, it's where we're changing from the central processing vessel becoming disposable. I think in the past it's been around the periphery with buffer bags and filters, but now we're actually going more towards a completely disposable plant. So I'd say this is starting to become a revolutionary change.
How do you measure the impact of single-use components on your ways of working?
We're always under pressure in terms of numbers of people within the facility, and really, the impact of single use is that we can actually make more product with fewer people. So, in effect, we've been able to upscale from 750 liters to 2,000 liters, but not actually increase the headcount. So, I think that's how I would measure the impact of these new components.
The turnaround times with new components will also be reduced, and the time when the facility is not in a productive mood are reduced by changing to the disposables.
Is the impact clearest in financial terms, in quality, in time savings, or in operator convenience and efficiency, or all of these?
The simple answer is all of those.
In what areas would you like to see further developments in disposable components and their use?
In the close future, I do believe that the focus will probably be changed from upstream to downstream. With new technology, it will be possible to contain also the downstream processes.
Do you think the scale of operation and scalability of disposable bioreactors is adequate today?
Yes, we do believe that the 2,000 liters size will be sufficient for most operations. If you are in need for more or larger tanks, larger capacity, it would probably be wiser to stack more 2,000 liters bioreactors. That is to reduce the risk of infections and so on. And that probably will give your facility a higher outcome compared to buying one much larger bioreactor.
What about product recovery?
Today there is typical two ways to perform product recovery. That is with single-use filters for clarification, or it is with centrifuges. Centrifuges are not that good today. If you're talking disposable centrifuges, you would probably going to need, if you go for a centrifuge, you would probably going to need one made of steel.
And just rule of thumb is that if you're doing over 20 batches of a year of a 2,000 liter, then a centrifuge starts to become more attractive. If you're doing under 20 runs of a year of a 2,000 liter, then definitely depth filtration is a significant advantage. And that's just in general.
Are there adequate filtration solutions, or are we looking for a disposable centrifuge?
Currently, there have been some big steps made on the filtration side to actually get filters with a larger capacity. Of course, we would like to see a further development and even increased capacity for the filters for the future. For the centrifuges, we still do believe that that disposable centrifuges might be useful in the future, but today we don't see good alternatives.
The other thing to bear in mind is the capital expenditure on a disposable centrifuge will be quite a bit more than on disposable filters.
Chromatography is doing much of the purification work downstream, but reuse is the best way to get good economy rather than single use. What is your take on this?
Today, yes, for chromatography, you're going to need to reuse the resins. They are very expensive, and they could cost more than half of production cost for a campaign. If we look into the future, I do believe that we will see different options compared to the chromatography. We will see even more charge filters used in different process steps, and perhaps we should think out of the box. In the future, we will have affinity ligands bound to microcarriers, and perhaps we're able to perform the chromatography already in the bioreactor. If that would be the possibility, then we could reduce the volumes that comes out of bioreactors, and we could reduce the need for filter. So if that would be a possibility, I think that could be a way to cut costs even further.
What do you think about the environmental impact of using single-use systems?
If you compare the waste from a manufacturing site as us, compared to the waste from a regular hospital or from the homes, the waste will not be significant. And if you're using the waste for landfill, of course it's a waste of resources. But if you're using the waste as an energy source, the impact on the environmental will be limited.
Are there issues with the actual disposal of components?
The disposable components normally contains several mixtures of several materials that will make it hard or impossible to make material recycling. You will probably continue to need to use them as an energy source.
So incineration is the best option.
What do users like you think about the issue of single suppliers of certain disposable components?
Again, when you're talking about IP, you cannot get away from this. In effect, say you have a disposable bioreactor and there is IP related to that, then in effect when you buy the holder, you're duty bound to buy the supply from that supplier. What you then do is a very good audit of that supplier to make sure that they can continue to supply and maybe have multiple sites at which they can manufacture. I think the other tactic to use is to always pick the market leader of that area in terms of number of units, so that in effect they're well tried and well tested. It gives you a better chance of success yourself.
Often products have unique features and are not interchangeable, making you rely on a single supplier. Does this expose you to extra risks?
Yes, but I think the main thing there is to do a very robust audit of the supplier and just, as I say, just follow your quality auditing procedures and make sure that they can actually provide backups and stock and have multiple sites. So it's down to good auditing of your supplier, really.
Do you see the industry evolving so that single-use equipment suppliers and biological manufacturers will work closely together on uniquely tailored solutions?
I would say that is already happening. We already work very closely with 3 different suppliers, and certainly they are providing us some custom-made approaches. So yes, I think we as a company are really limited to 3 main suppliers. Trying to deal with any more than that could be problematic, certainly in terms of product development.
On the one hand, single-use components seem as though they will reduce manufacturing risks, such as cross-contamination between batches or bioburden. On the other hand, leaks in plastic bags and connectors would have catastrophic consequences. Can you comment on these things?
Yes, I've commented many times on this particular topic. I see single-use in this area as a distinct advantage. On a number of occasions using stainless steel, I've had leaks on tanks, And the problem there is you don't have a spare tank to put the product in, and it significantly puts the product at risk. With disposables, what you can normally do is, if you find a leak, is you can normally pump it out of that bag through a sterile filter and into another bag. That's a distinct advantage over stainless steel. And it's one that isn't normally quoted, but it is actually, from an operations standpoint, a big advantage of using single use, for the simple reason that you can have those backups to hand.
Once there was a utopia described where the use of disposables would allow you to use a very simple facility design with a large single production space. Product containment was at the equipment level. What are your thoughts on this today?
As I say, I actually speak on this topic. I think it's always a balance. If you, say, have a multi-billion-dollar blockbuster drug, you'll maybe take a much more conservative approach to a small contract manufacturing service. So I think it will be tailored towards the products concerned. I think with certainly large multi-billion-dollar projects and products, you will stick to a relatively standard or a relatively conservative design. But where you need small products with lots of flexibility, then you may approach factories with a much more open space type of approach. But I think it will be a case by case, and it will be dependent on the amount of risk the particular factory wants to take. The main advantage with disposables, whether you take the conservative approach or the non-conservative approach, both these factories will be smaller in footprint than their stainless steel counterparts.
Do you see prospects of running separate products side by side in the same hall, sharing some pieces of equipment? Please explain your view.
I have in previous employment done exactly that. I think as long as you've got a very robust approach to containment, then it's feasible. It's then down to risk of, as a company, do you want to do that or don't you? It's certainly possible, and Christopher was mentioning that there's certainly a move going towards more contained purification, and I certainly have a vision of the 2,000-litre suite here in Copenhagen being a completely dry suite, where there is no liquid anywhere other than inside the tubes and inside the bioreactor. The technology is out there to do it, and then it's just down to the individual companies and their own risk assessments as whether they want to do it or not.
David, Christopher, thank you for sharing your insight today.
Thank you.
You're welcome.